In this section, we're going to take a look at the law of cosines and how the law of cosines can help us solve side-side-side triangles. Let's look at an example. Solve the triangle with side A equal to 8, side B equal to 5, and side C equal to 4. Round to the nearest tenth. So we have side A equal to 8, we have side B equal to 5, and we have side C equal to 4. This is an example of the side-side-side triangles where we can use the law of cosines. In fact, we have to use the law of cosines because we don't have an anchor. We can't use our SOHCAHTOA rules because we don't have a right triangle. All we can use is law of cosines. And what we want to do is solve for those three angles. So I can start with whichever angle that I like. I'm going to go ahead and just start with alpha and use the length of the side that's across from it. So for alpha, I know that I need to set a squared equal to the other two sides squared. So that would be 5 squared plus 4 squared minus 2 times 5 times 4 times the cosine of alpha. And when I get alpha by itself, or I should say when I get the cosine of alpha by itself, I'm going to put into my calculator 8 squared minus 5 squared minus 4 squared all over negative 2 times 4, negative 2 times 5 times 4. And when I did that, that gave me, let's see, I got the cosine of alpha was approximately negative 0.575, and taking the inverse of each side, I got around 125.1 degrees. And, it makes sense to me that that's a fairly large angle only because this side of 8 was the largest side. So I would expect that the largest side is across from the largest angle. Okay, let's go to beta now. And I'm going to do exactly the same process, but I'm going to say, let's see, where can I put this? I'm going to say that across from beta is 5. So I'm going to say that 5 to the second power is equal to 8 to the second power plus 4 to the second power minus 2 times 8 times 4 times the cosine of that angle beta. So the cosine of beta, is going to equal 5 to the second minus 8 to the second minus 4 to the second all over negative 2 times 8 times 4. And when I put that into my calculator, I got that the cosine of beta is equal to 0.859. And if I take the inverse of each side, I got that beta was approximately 30.8 degrees. 30.8 degrees. Let me go ahead and mark that. 30.8 degrees. So I now have 2 out of the 3 angles. And so to solve for gamma, gamma is simply going to be 180 degrees minus alpha, which was approximately 125.1 degrees. Again, I'm going to put the actual number in there. And then I'm also going to subtract out the 30.8 degrees, the actual number for that. And when I did it, I got that gamma was equal to approximately 24.1 degrees. Gamma is 24.1 degrees. And the last thing that I can do, just check this, is this make sure that the largest angles are across from the largest sides. So I said 125.1, that would be first. And then let's see, the smallest would be gamma. So the order here should be that gamma is less than beta is less than alpha. And if that's true, then across from gamma is side C, and across from angle beta is side B, and across from alpha is side A. Is side C less than side B less than side A? And the answer is yes, and so that checks.